This is part 3 of section 1.4. We want to determine algebraically whether the given functions are even, odd, or neither. So what we're going to be doing is we're going to take, for both of these, it requires that you plug in negative x and then simplify. If we plug in negative x and we end up, after we simplify, with exactly the same function, it's going to be even. If, after we plug in negative x, we are able to factor out a negative, and what we have left is exactly the same as our original, it is odd. If we have anything else happen, it's neither. Okay, so if I want to find out whether this is even, odd, or neither, I'm going to figure g of negative x. So that will be 3 times negative x to the 4th power minus 5. Now remember, you can think of this as a negative 1, and one of our exponent properties looks something like this. You may have learned it with different variables, but so I can take this 4th power and put it on each of these. Raising negative 1 to an even power is just 1. So this is 3x to the 4th minus 5. This negative went away because it was absorbed by an even exponent. Now, so we've plugged in negative x, we have simplified, now we compare. Since this is exactly the same as this is an even function. Now we can't be both even and odd, and even will be the first one, always be the first one you are able to verify. If it were not even, then I would go on and try to figure out if it were odd. But since I found out it's even, we can stop, we've got our answer, we're done. So now do the same thing here. Plug in negative x, and we have 2 times negative x cubed plus 4 times negative x. This is, when you raise a negative number to an odd exponent, it stays negative. So this is negative 2x cubed minus 4x. So we've plugged in negative x, we've simplified. Ask yourself, is this the same as this? No. So I know that this is not even. Now I'm going to figure out if it's odd. And the way we do that is we factor a negative out of this to get negative parentheses 2x cubed plus 4x, and then now compare this part to this part. Is it the same? Yes. So we plugged in a negative x, we simplified it, we were able to factor out a negative and then end up where we started from, so this one is odd. Okay, let's do the same thing here. G of x is equal to 3x plus 7. Let's plug in negative x. And we get 3 times negative x plus 7. And that would be negative 3x plus 7. Now, is this the same as this? No. So it's not even. So let's try factoring a negative out. That will give me 3x minus 7. Now, is this the same as this? That's still no. So this one is also not odd. So this is neither. It's not even, it's not odd. Okay. Now we are going to work one more example of this, but before we go on, I want to show you a bit of a shortcut. Okay, so all of these are polynomial functions? Basically, we have no fractional exponents. We do not have variables in denominators, and we don't have variables as exponents either. These are plain old everyday polynomial functions. Okay? And if you have a polynomial, you can use a shortcut. It does not work if it is not a polynomial. You're going to have to do it the long way, which is what we've just done here. And with a polynomial function, once you see this trick, you'll understand why mathematicians decided to call them even, odd, and neither. What I want you to look at is the exponents on your variables in here. One thing you do need to remember is that x to the 0 power is 1. So anytime there is a constant, I can write if I wanted to rewrite this and I wanted every single term to have an x value in it, I could rewrite this as 3x to the 4th minus 5x to the 0. Because x to the 0 is 1, negative 5 times 1 is still negative 5. Okay. So, and then right here, I could write it like this. On this one, if I wanted to, I can put a first power there, and that would be 2x cubed plus 4x to the first power. And then right here, this is the same as 3x to the first power plus 7x to the 0. Now, I know you won't need to write all that out, but it's just for reference at this point. Now, look right here. We have a 4. And we have a 0, and these are both even. And this was even. Look right here, 3 and 1, those are both odd, and the polynomial was odd. And then finally, right here, you have a mix of even and odd. So it ends up not being either one of them. So if you have a polynomial, you can use this trick. It just doesn't work if it's not a polynomial. Okay, now let's look at one of those where the trick will not work. This is a rational function, not a polynomial, although it does have polynomials in the top and in the bottom. But if we want to know whether this is even, odd, or neither, we're going to have to do it the long way by plugging in negative x. So let's figure g of negative x. And that gives me negative x to the 4th plus 3 over 2 negative x cubed minus 3 times negative x. A negative number raised to the 4th power is still positive, so that's x to the 4th plus 3. And if I'm paying attention, this numerator is the same as that one. And if we think about it, both of these had even exponents, where that's x to the 0. And so the top should be even. Here, I have a 3rd power and a 1st power, so this bottom should be odd. Let's do that. If I plug in negative x and raise it to the 3rd power, that gives me negative 2x cubed, and this becomes plus 3x. So now what we do, we've plugged in negative x and we've simplified some. Is this exactly the same as this? No. So this is not even. Okay, now to determine whether or not we have an odd function, we're supposed to factor a negative out and then see if we get the same thing. When you have a rational expression and you want to factor out a negative, you factor a negative out of the top or the bottom, but not both. So since this is already the same as this, I'm going to factor a negative out of the bottom and see what I get. So I would have x to the 4th plus 3 over, factor out a negative, 2x cubed minus 3x. And then this is the same as just putting a negative out in front. And now ask yourself is if this part is the same as what we have here, and it is, with a negative in front, so this is an odd function.